Hi and welcome to the Machine Ethics Podcast. This month I'm with Rob Wortham at Bath University. We're talking about the mind model that people have for robots, principles of robotics for creators, intelligence and doing the right things at the right time, autopilots, software as being quite unregulated, and some of Rob's research. You can find more podcasts from us at machine-ethics.net. You can find us on Patreon at patreon.com/machineethics. Please enjoy the podcast. Hi Rob, if you'd like to introduce yourself briefly and what you do at Bath University, that'd be great.
Yeah, so my name's Rob Wortham and I'm a PhD student at the moment in my third year, and I'm part of the computer science department, and I'm interested in robots and how they work, and specifically how they interact with people, and what's the nature of that interaction. So what I'm really interested in is the nature of the interaction between human intelligence and machine intelligence, designed machine intelligence, and the kind of models that end up being in the minds of those people when they interact with the machines.
Yeah, so it's kind of it's how people anticipate what they're seeing in the robot, almost.
Yes, yes.
Yeah, how they approach the robot.
Yeah, so it's things like how smart they think the robot is, how much thinking's going on in the robot, what's the capability of the robot, what's the objectives of the robot, what's it been built for, what's it trying to do, what kind of sensors does it have, is it seeing them, is it hearing them, can it see them move their arms, those kind of things, and how aware of its own environment is it.
Yeah.
So and those are things that people are pretty bad at being able to estimate. So we have a mind model of a dog, for example. When we encounter a dog, we pretty much know what a dog is, what it can do. That we know, for example, that it can smell very sensitively. We know that it can see its environment. We know it can hear. We know roughly how fast it can move. We know probably what it's thinking about, probably food or other dogs. So we know, we have a model in our mind of a dog. When we meet a robot, we won't have any of that model.
Yeah.
Not only because we don't really encounter robots very much at the moment, and we will much more in the future, but also robots are designed, so they're not all the same. Whereas, dogs are evolved, so all dogs are pretty much dogs.
Yeah.
Whereas all robots can be very different to one another. It depends what the designers decided to put into that machine.
And also, I guess, in a similar way, like if you anticipated something that looked like a dog, which wasn't a dog, you could probably, something that you've never seen before, you could probably kind of use some of that knowledge that you possess to make an assumption about that thing. Whereas with robots, there's such a plethora of different, massively different capacities.
Well, all evolved animals
have
basically got those four same drives. Okay, they're going to fight or they're going to flee, depending on how they perceive a threat. They're going to need food, and we'll include water with that. So they need, same as we do, they need to eat and drink, and they need to mate, and their objectives are very egocentric, to benefit themselves. A machine, on the other hand, can have very different goals. It's benefiting not itself, but the person that designed the machine for some other objectives that the person has in mind who designed the machine.
Yeah.
So it's completely different. And then, of course, you've got this question about is it remotely connected to something? A dog is not remotely connected to anything. But a machine might be connected to the internet wirelessly. Might be. It might be streaming the video that are coming from the cameras. It might be streaming the audio. It might be recording that information.
Yeah.
There might be more intelligence remotely controlling the machine. So what you're looking at there may not be all that's going on.
There's in Korea they have a law that says if you take a photo in public, you have to have the sound on the phone.
Oh, right.
So do you think that these sorts of things will come into what you're looking at, into robotics, where there has to be a certain amount of explicit knowledge shown on the machine that it's going to be recording, it's going to, lights or noises or labels, or is there sort of like an easy win there, or is it more difficult than that?
I think there are easy wins, yes.
Yeah.
In terms of some very basic regulations for these machines. At the moment there's no regulations. There is a set of principles. So there are these principles of robotics that were produced in 2010 by some academics, lawyers, ethicists, different people got together and produced a set of principles. These are not the principles that you put into the robots. They're not like Asimov's principles.
No.
These are principles for the designers of the robots.
Right.
And operators and everyone all the humans who are making that robot do what it does. So that's great. One of the principles, which is the one that I kind of focus on, which is number 4, is that the robot shan't be designed to be deceptive. So so as you're saying, it should be very transparent and plain what that robot's doing. So if it's recording, maybe it should have a big light that says I'm recording and it flashes away, or it should tell you that if it has speech capability, or so in some way it's making manifest what it is and what it's doing. At the moment, that those principles are not really regulated. So there would be, if you're recording children, for example, then that would come under other types of regulation, which we know about already. But there's no specific regulation for these machines. The IEEE are working on a set of regulations for AI and autonomous systems. But again, that's just and the EU have some draft legislation which is at a very, very early stage, which they're looking at. But no, at the moment you can build a machine. It can wheel around.
You might have to put
unless it's a trip hazard or something.
Then exactly. Like this is 9 volts, and there's a set of technology-based things.
So you have to have a CE mark on it, but that would probably be just that the plastic wasn't that flammable, or that the battery wouldn't catch fire, or just things to do with the hardware.
Not that it's beaming information about you elsewhere.
No, exactly. Or trying to lead you off to somewhere where you don't want to go, for example, or give you disinformation.
The first question I usually ask people is a tricky one. What is artificial intelligence?
To me. So first of all, we have to look at what intelligence is, right? Let's just look at that, and then it gets easier. So intelligence is, I would go for a very broad definition, which just says it's about doing the right thing at the right time. So a stone doesn't do the right thing at the right time, it just sits there in the sun, right? It doesn't actually move, it's inanimate. But a plant does do the right thing at the right time. It senses its environment, and it puts leaves out at the right time, and it moves its leaves towards where the sun is. That's that simple phototaxis, so it moves itself towards the sun. So I would say that a plant, a tree, would be an intelligent thing in that sense. It has no central nervous system, it has no brain, but it does behave intelligently. So given that very broad thing, then an intelligent agent is simply something that senses its environment. It has some internal objective or plan for how it wants to change the world to its benefit. And it has some ability to interact with the world to affect that change. And then a robot is just a physically embodied. So agents might just exist inside machines, inside computers. They could exist on the internet, they're not physically embodied. But a robot is embodied as well, so it has it physically interacts with the world, arms and legs, sensors and so on.
Yeah. Do you see, in your mind, most of these robots embodied with the intelligence kind of on board, or is it more of there's the instructions being sent to the robot and the robot is enacting those instructions? It's kind of robot is larger than itself, or the robot is itself contained.
Well, I mean, early robots obviously had industrial application, manufacturing cars and so on. They're very, very powerful, very precise, very quick machines, completely unaware of most of their environment. So if you got in their way, if you got inside the cage where the robot was kept whilst it was welding cars together, it would just swipe you and kill you. And those obviously had off-board processing going on, so a big set of wires that would come from the machine to a big computer somewhere. Mobile robots now, because of the miniaturization of electronics, are able to carry all of the necessary compute capacity. And the bigger problem is probably power. It's probably one of dragging the battery around with you. The power source would be the major problem. In fact, that kind of leads me on to say that the big problem really is not the compute side of things and the intelligence side of things, but it is the physical embodiment. That's really still where the challenge lies. if you want to make a robot do something useful, like make your bed,
Yeah.
then the really hard thing is making a machine that can push material into the bed and fold the sheets and make the bed and put the pillow into the pillowcase is probably a very difficult thing for a machine to do. It's not so much about the compute resources and the artificial intelligence side of things.
Yeah, so it's more the manipulation with the real world and that sort of side.
And this is really why we're seeing social robots proliferate. So we're seeing a lot of companies selling social robots that mechanically are very, very simple. That makes them cheap.
Yeah.
But what they're good at is all the social interaction with you. So, for example, they can pick up on your tone of voice and the kind of language that you use, and can assess your mood from that. And then they can interact with you appropriately to your mood. So they're socially aware. There are machines that will do gaze tracking, so they'll see where you're looking.
Yep.
And then they'll follow so that they look in the same direction that you're looking, which of course all us animals do. Dogs do it, cats do it, and then that works cross species, doesn't it?
Yeah.
So if I look at something, I'll make the dog look at something. But now these robots can do that.
Right. So that part of that sounds like understanding our own human nature before then embodying it into the robot. Because
I don't think they necessarily need to understand. They just need to mimic certain things, certain behaviour. So the machine doesn't need to have any deep understanding of what it means to be depressed. It just needs to be able to pick up, okay, this person is showing signs of, from the way they speak and so on, that they're in a low mood, and therefore I will respond algorithmically in some way as if I have a deeper appreciation of the way that they're feeling.
Yeah.
Which of course is deceptive.
Sure.
Because you might think, oh, this robot really understands me.
So this is where the ethics comes in.
Yeah,
isn't it?
exactly.
Yeah,
This robot really understands me. Look,
Yeah.
it's got its sad face on because it's seen my sad face.
Yeah.
But there is no deep understanding, contextualized understanding.
Yeah.
There is no grounded understanding of what it means for a human to be in a low mood, because this is a machine that's just designed to sort of simulate that empathic response. It isn't. I mean, it's a philosophical point whether it's truly empathic or not truly empathic. But I think with the current capacity of those machines, you've got to say that machine isn't having true empathy for you.
Yeah.
It's simulating that empathy.
Well, it's not simulating empathy. It's simulating humans appreciate as signs of empathy.
Yeah.
Rather than any internal knowledge of.
Yeah.
That
but
feeling.
If it speaks to you, then the language it uses would be language that may be tuned to be the right kind of language to speak to a person who's in low mood, and it might, exercise its cheer up the other person protocol or something. It's just
or not, depending on who's designed it.
Yes, exactly.
Yeah. What do robots think? I noticed that you had a few publications recently, and one of those titles really struck me. It's a good title. I feel that I was just wondering if you could expand that thought process.
Yeah. So one of the experiments I asked people, is the robot thinking? And people were pretty split on that. I think probably that's more about what they think thinking is more than anything. For me, a robot does have a mind. It does have a computational device, which I would say is a mind, a very simple mind. If you look at the mind of an ant, for example, it's very, very determined by the genetics. An ant learns very little during its lifetime, but it's able to interact with the world, much like a very simple robot is able to do that. And I think you would have to argue that an ant has a kind of mind, as Dan Dennett says, the philosopher. There are different kinds of minds. So first of all, I would say that the robots think. But what I would say is that the depth of their thinking isn't the same as the depth of human thinking. Having said that, humans don't necessarily use a lot of thinking that much of the time.
Right.
A lot of the way we behave is very programmed responses that don't require a lot of active thought. but do require a lot of computation. So when I walk, I have to balance my body.
Yep.
I have to not bump into things. I can do all of that while I check my phone. So my conscious attention is on my phone, but actually the subsystems in my body are enabling me to walk along. Actually, out the corner of my eye, I can avoid people. There was some research done on that recently. People who are looking at their phones don't bump into people on the street. Their peripheral vision allows them to be able to identify obstacles and avoid them.
Yep.
So there's a lot that goes on that you're completely not consciously aware of. And that's the same in a machine.
Right.
So what do the robots think? Well, what do they think? It's an interesting question. I guess what goes on is is processing, right? What is thinking?
Yeah.
Thinking is processing information and
Yeah,
making
and
decisions based on that processing.
And doing the right thing at the right time.
And doing the right thing at the right time, as I said, that's what intelligence really is.
Yeah. Cool. What other projects have you done in relation to this kind of idea of transparency with the robots?
So we built this small robot, which has a very simple Darwinian type of a mind, just determined by its programming, by the designer, with very little learning going on. So a bit like the mind of an ant. And we just allowed people to encounter this robot. We did that. First of all, we did it online by videoing the robot, and people could watch the video. And then we did it in the Science Centre in Bristol, which is a place where people go to learn about science and take their kids along. It's a very practical kind of thing.
At Bristol?
At Bristol,
Cool.
Bristol. Who were fantastically helpful actually with my research. So hats off to them for being so helpful. But so what we did is we just showed people the robot and then asked them some questions, and then we showed them the robot alongside a graphical display of the processing that was going on inside the machine as it was operating. So just the decision processes really. This very simple little block diagram display and when the robot was actively doing something, that little block, the relevant block, would light up.
Yep.
So a very simple display. And then we asked people the same set of questions and compared the two groups to see how accurately the model in their mind that they'd formed about what the robot was doing and what its capabilities were matched the actual capabilities and functionality that's inside the robot. That was really interesting. The most interesting thing, I thought, I mean, their mental model massively improved when you showed them the graphical display.
Right.
But they didn't know that it had, and that for me was really interesting. So in both groups, about 80% of people said they understood what the robot was doing.
Right.
In both groups. But in one group, very broadly, they were half as right as in the other group. Okay, so we scored their responses, and the group that had the graphical display got twice the score as the group. It still wasn't brilliant actually.
Yeah.
But it was twice as good. So I think that was really interesting because it just shows you that people don't necessarily know that they don't know.
Yeah, what's going on?
What's going on? Yeah, exactly. So we did that, and then we went back a few months later and did a subsequent study where this time we got the robot to generate sentences. So the same data feed was coming out from the mind of the robot, exactly the same feed. But rather than presenting it graphically, we turned it into sentences. It's very simple sentences.
Yep.
Just saying what the robot was trying to do at that point.
Yep.
And
can you give us some examples?
So So if when the robot is just moving around the environment, it would say R5 is trying to explore.
Right.
R5 is the name of the robot. So it just keeps saying, in a muttering kind of way, over and over again, R5 is trying to explore. R5 is trying to explore, you see.
Right, okay.
And then when it encounters an object,
Yep.
it would say something along the lines of R5 is avoiding obstacle.
Yeah.
And then when it avoided the obstacle, it would say R5 has avoided the obstacle, and then go back saying R5 is trying to explore. So that's really all that the mind was thinking.
Yeah.
It wasn't thinking anything else. There wasn't anything else going on.
Yeah.
So it wasn't mapping the area. It wasn't making a map. As a lot of people thought it was making a map, inside.
Yeah,
it wasn't. It wasn't really sensing humans at that point.
Yeah.
So it had a heat sensor on the front, and when it got quite close to people, it could sense the heat coming off their bodies, a bit like the sensor does on a building security system. You know, when you go into the building, a little light lights up in the corner. It's PIR sensor. So it sensed your heat. So it had this little PIR sensor. So when it sensed heat, it would stop, and then it would scan up and down to check the heat signature, and it was looking for if the heat signature is actually changing.
Okay.
So the idea was that you waved at the robot and your hand was moving across, and so it could detect that you were waving at it.
Yeah.
And if you did do that, then it would tell you it was detecting a human. It would tell you it had detected a human. Flash a green light. If it detected a radiator, not a human, it would flash a red light.
Right.
And then it will turn around and go and find some more humans.
Yeah.
It was very simple. So the robot was literally saying to you the steps in the action selection mechanism of the machine as it was doing that.
Yeah, that's really nice, because I think it's somewhat sophisticated in a way that it can detect things. But it's actually communicating it in a very simplistic way.
Yeah,
people can understand.
Yeah. So I had the idea that perhaps when you first get a robot, let's say you have a new domestic robot in your house, which would have to be more sophisticated than this machine that I built, maybe you could turn on the muttering, and it would constantly just tell you what it was doing, and that would be very irritating after a while. So you could just tell it to be quiet, and it would stop. But if at any point you were a bit confused about what it might be doing, you could just tell it to turn that on. And if you were confident that all that was going on was reflected in what it was saying to you, then it would become like a transparent thing. It becomes less like a person that has hidden motives and hidden objectives and so on, and much more just like a machine that's very transparent.
So you wouldn't wake up during the night and hear it muttering over you. So.
Yes, that's right. Yes, that's right. Kill owner, kill owner.
Kill.
Looking for knife.
Exploring.
R5 is looking for a knife.
R5 is turn the lights off. From my world of web design and online stuff, it sounds like looking at the logs, right? It looks like
yes, that's right.
That sort of
pretty
behavior.
much. That's really that's kind of what's happening.
Yeah.
So I think the key thing is that it's another mechanism that's bolted onto the side of the thing making the decisions.
Yeah.
It's not part of the decisions of the machine to decide what it's going to say to you.
Yeah.
So it's kind of
it's
like
kind
a window
of
onto the side. So as you say,
yeah.
exactly like doing something with a log file that's coming out of a web server or any other piece of software.
Yeah, cool. Well, that's really interesting. I think for me, the initial element there is just getting people to do it. You know, how do we actually get these sorts of things to be required by makers, or just a good thing to do, because for even web designers or developers of software, things like that, it's not a requirement that you do anything really.
No.
So doing things for the logs or doing useful things for users is more of a it's detrimental to the user, but it's not detrimental to money making necessarily. So as a big manufacturer making these things, they might overlook the sort of things because it costs them money to implement. It takes time, and it's not necessarily actually making it more useful actually.
Absolutely.
So
well, there's a big let's open this up a little bit wider and talk about ethical robotics in a much broader sense. If you say that these machines that we're making should be tools and useful tools for us, now, I mean, a useful thing is entertainment. Okay, so that's fine.
Sure.
But if you build a robot that's kind of needy, a robot that starts to need your input in order to function, you spend a lot of time worrying about the robot and whether you've made it happy, or whether whether it's charged up or if it's gone flat, and you start to worry about the robot. Tamagotchis, I think they were called years ago. I mean, that's like the absolute antithesis of something useful. It's something which actually just burns your time, and you worry about it. And little kids would worry that something bad was happening to their Tamagotchi when they went on holiday. How is that helpful, really? And if we start to build social robots that are doing that kind of thing, how is that really a useful contribution? So I'm firmly of the opinion that the robots need to be considered to be tools and to to have all kinds of useful applications. But as I said earlier, it is hard to build a robot that makes the bed, which would be a useful thing.
Yes, yeah.
Or accurately picks things up off the floor for an old person so they don't have to bend down when they drop something, or just pick something up off the floor for them. But much easier to build a wheeled base, low cost, just wheels around, has an LCD screen with a face painted on it, and then it interacts with you socially and just chews up your time and attention.
Yeah.
And that's why manufacturers will not particularly be incentivized to build useful and transparent machines. They just want to sell units.
Yeah.
It's a bit like, I think, a lot of social media, which just burns a lot of time fairly unproductively, and is addictive.
Yeah,
you know, it presses our buttons. It hyperstimulates us, and it presses all of the right buttons in our heads to make us want to keep checking it and keep. You know, it's like news feeds. You know about temporal discounting of information. So that's the. So when you're hunter-gatherers, it would be good to know where the food was quick, so you can chase after it, and it would be really useful to know where the lion was that was coming to eat you pretty quick.
Sure.
So if you knew about that, if you were the last person to know about that, probably not much help, because the lion would probably be going to have you. So that's why we do gaze tracking. So if someone else has seen something interesting, you are able very accurately from their eyes to see what they're looking at, and that's for the reason. That's the reason. So you don't want to be the last, you want to be the first or close to the first. So information that's old is much less valuable than information that's fresh or new, and that's kind of biological programming. So that's called temporal discounting of information. That's why when your phone goes ding, you think, I must know what that is. I'd like to be the first in my social group to know about whatever the thing is. I can put it as a post to other people on Facebook, or I can tweet it before anybody else tweets it.
Yeah.
So that's a kind of addictive, because it's just pressing on that mechanism that we have evolved in us, and finding a new use for it, but it doesn't necessarily benefit us. Benefits other people.
The advertisers.
The advertisers. The people running the social networks, the advertisers, all those people. So that's the concern. That's the concern about building a machine that would do that.
Exactly, yeah. So we shouldn't take that notion through into machines which are then going to be physically embodied in our homes or factories or whatever. Cars, planes, just wherever we are, I guess.
Wherever we are.
Yeah.
The shopping experiences as well.
Yeah.
You know, we got online shopping already, which, you know, other people that bought this also bought these other things.
Sure.
But maybe in physical shops you can have robots. You know, you look great in that, says the robot.
Yeah. Thanks.
Well, you could say it's no different to the sales assistant saying you look great in that, because that's, you know, that's not.
Yeah. Well, at least I can look them in the eye and see how.
And that comes back to the theory of mind. You probably can tell if they're lying. You've got more chance, or you've at least got some way to calibrate your trust.
So given actually your log or transparency thought process, maybe we'll have a lying symbol come across. So it's like, you look lovely in
this
that.
is an insincere robot.
Exactly. That was a lie.
We just need some way to be able to calibrate our trust in these things, just like we do. You know, you trust a bank teller with your information much more than you would trust a supermarket shop assistant, because you know the consequences for the bank teller are very, very high, very serious, blah blah blah. So you calibrate your trust in terms of the privacy of the kind of information that you give to people. So we understand that in the physical world. But in the cyber world, you know, people have trouble. I know that I have elderly relatives who are really unsure. Can I type my credit card into this website? Is this a real website, or is this a scam? They can't really tell what's a scam and what's real. When they get letters through the post, they find it very difficult to. And I think it's just because everything's changed so fast. So this is another step in that. This is just a more embodied experience.
I mean, when I was looking at some of your work, I was struck by how interesting that kind of transparency idea was, and also how that applies to lots of different robots with different types of functionality and kind of interaction. So it's really interesting how if you had one type of robot that existed, it would be quite a simple implementation.
Yes.
Kind of exercise. But given that there's lots of different things and they will continuously be upgraded and improved, it's going to be interesting how that kind of plays out across the plethora of these different types of robots and their different.
That's a good point, and we see that now. You have a mobile phone in your pocket, which is a kind of robot, and of course the software on that gets upgraded. And you just always click OK because you want the latest software for some good, sensible reasons like security and so on. But you don't know; it changes each time.
Yeah.
So the same thing will happen with these kinds of machines. You'll download when you buy them. They have a certain set of capabilities, and as you say, that will upgrade and change over time.
Yeah. I think there was a really good example of this. I think we talked about a couple of episodes ago with the Tesla, because the Tesla cars actually you can opt in for them to upgrade as you go.
Right.
So certain models are young enough to be constantly upgradable, and with those upgrades, via Wi-Fi or whatever, come new experiences, new functionality. But you have to then be educated at what that is. So the autopilot has just changed and it's got better in these ways. How does this affect you? And you need to basically have an educational video about, the new way you have to interact with your car.
Wow.
Each time.
Yeah.
Each time this happens. And being not a Tesla owner, unfortunately, as far as I know, that doesn't happen, right? So you have to read the T's and C's each time, or you have to read some information each time, but you don't necessarily get that educational bit with each new improvement to the experience. So I think that's quite interesting as well.
And also, if you were fortunate enough to be a person who drove multiple Teslas for some reason or other.
Sure, yep.
And if you just widen that a little bit and say there's lots of autonomous cars, but with all different capabilities, when you got into your autonomous driving machine, you wouldn't know how autonomous it was, at what point you were supposed to take control, at what point. So I think the idea of reading the manual is not good enough.
Yeah.
The machine needs to be transparent and tell you everything that you need to know to be able to interact with that machine in a safe way.
Yeah.
The days of saying, well, you didn't read the manual or you didn't read all the terms and conditions, it doesn't really. It's not enough, is it? It doesn't.
Definitely.
Yeah.
So how do we move forward from here? Given the experiments that you've done, the projects that work on, is there the next step sort of thing that you're working on at the moment, or going to look at in the future?
What I'm actually doing at the moment is trying to write up all the stuff I've done and then put it all together and then write my thesis and get my PhD.
Nice.
So that's really what I'm going to focus on in the next year. But I think more broadly, it would be great to see some initiatives from industry to set some standards, some about things like how transparent is a machine. So you could still have opaque machines, but at least people would know that they are, they have a transparency score of 0 or something, and they could calibrate their trust appropriately to them. Or we could have more transparent machines that you could trust more. So maybe some kind of scale would be a good thing. Maybe some independent assessment of these machines. So in the way that to get a CE mark, I'm sure you have to have some sort of assessment of the design of your product and submit a sample and all that kind of thing. Maybe some kind of scheme like that where people would award it some star rating or something like that.
Yeah, definitely.
The European legislation about cars, which I think ethically is somewhat problematic, is that you sue the car.
Yeah.
So the idea is that if the car causes an accident, then you sue the car. Right. The car has to have its own insurance policy, and then that insurance policy pays out.
Right. Yeah.
Okay. This would mean that insurers would all of a sudden become very interested in the capabilities and capacities of the car.
Yeah.
So they might start to say, well, we're only going to insure these vehicles if they meet certain standards.
Yeah. Yeah.
And that might be a way to start to give these standards some teeth commercially. So yes, you can build whatever car you want, but you can't get insurance for it. If it's not insured, you can't run it on the road.
Yeah. So
therefore, it has to be built to a certain standard that the insurer is prepared to insure it for.
Yeah.
So that's the positive side of it.
Yeah, I think we had Matthew Shannon on a couple of episodes about insurance specifically, and I think that's a whole big kettle of fish right there.
Yeah.
And it's to do with that. What are the different compatibilities of the vehicles? What are the vehicles doing differently from each other?
Yeah.
And how's that implemented?
But you imagine jumping into a car,
Yeah.
just to rewind a little bit to where we were discussing a minute ago, and not knowing what the capacity of this vehicle is.
Yeah.
I mean, previously to that, you could always drive a car, it has gears, and it drives, and you driving it.
Yeah.
And now, all of a sudden, they've all got different capabilities. It's
I think
a very problematic
from
world.
From my vantage point, having talked to some people about this, I feel like there does need to be some sort of base level. And for me, the easiest way of doing that is going, no, there is only one autonomous car. There's only one person who's making this car in the UK, who's allowed to use it, and he does this. And I feel that's the easiest way of doing it. If we have tens of different autonomous vehicles, I think that's going to be...
for me, I think the graduation of autonomy is the problem. I think either you're driving the vehicle, or you're not expected to drive it at all.
I think that's where we should be before we talk about it.
Yeah.
I think it's just out of your control.
Yeah. So Google, their initial idea was to build cars with no steering wheel.
Yeah.
And whilst you might want one for some kind of other reason, you probably want that as being the minimum standard for a self-driving car. It is self-driving. It doesn't need... You could drive them around without people in them.
Yeah, definitely.
And that then means that the person is absolved from this very grey area of responsibility about in what sense am I driving the car and in what sense is the AI driving the car.
And that would make it easier for the insurance problem as well, because then you wouldn't have that muddy ground of the person. Some of those cars, like the Tesla, for example, the person is required to take control at certain points when on autopilot, and having all these different types of scenarios makes it very difficult.
It's unreasonable to expect a person to monitor something that's autonomous for long periods of time,
especially if it isn't transparent.
Yeah,
as well.
Yeah. But airline pilots tell me this, that they sit in a plane for many hours at a time whilst the autopilot flies the plane.
Yeah.
They're not really aware of exactly what's going on, how the plane is being flown. They don't have their hands on the control. They're not in the loop of the control.
Yeah.
And then if something goes wrong with the autopilot, they have to rapidly get in the loop and re-establish their control. And they say that's really difficult to do because they're not part of the total control loop, and then all of a sudden they're supposed to jump into it and then assume control.
Yeah.
And you can't expect them to sit vigilantly to try and notice exactly what's going on. So, for example, in a self-driving car, you couldn't expect them to sit there like a passenger, constantly looking out for pedestrians or vehicles, just in case the machine doesn't notice one of them. It's too much.
Yeah.
Too much to expect a human to be able to do that.
Yeah. And it's unfortunate because if we were better, if humans were different, then you would. But knowing what we know about human psychology and attention and all sorts, and just sensory world, we just can't do that. It's not possible.
It's not possible, no.
So I've got a bit of a strange question here: neural-nets or genetic algorithms?
Let's just very rapidly just go through what that. So a neural network is something which is trained on a lot of historical samples of data.
Yep.
In order that it's effectively predictive. It's learnt some sort of complicated transfer function between a set of input variables and a set of output variables across a large number of samples.
Yep. And
then when you put a novel input in, it's able to predict what the correct output would be.
Right.
And then normally those networks are trained, and then when they're actually run in production, they're not trained anymore. Okay, so you have like a two-phase process: a process of training the neural network, and then a phase of operating the neural network.
Yeah.
The problem with them is that the neural network can't really give you any narrative for the decisions that it's making.
Yeah.
So it just has inside it a set of nodes connected together with various weights, the amount of contribution that this part of the neural network is contributing to the output decision and so on, positively or negatively. So it's just trained based on the data, and it can't give you a narrative. So for example, if you have that in a credit scoring, and it takes in all kinds of information about you, your age and your job status and your salary and whether you put a mortgage and all kinds of things like that. And then it says this person's a good credit risk or a bad credit risk. It can't give any narrative for why that is the case, other than to say, I was trained on 10,000 samples of data, 100,000 samples of data of people, and some were good and some were bad, and you match the bad ones more than you match the good ones.
Sure.
That's a neural network. Genetic algorithm is something which uses the idea of from genetics of being able to make gradual changes over time and then see whether those gradual changes are beneficial or detrimental. So what you need to do there is run things over and over again. So for example, one of my colleagues, his PhD was about controlling an AI character in a video game, and he had a control strategy which was a set of a readable plan actually for how you would control this machine. This little agent in this video game, and you'd see what score it got. And then you'd make a change. In fact, you'd make a whole bunch of changes to the plan. To create maybe 20 variants to that plan, and you'd run those 20 variants again, each one of them, see which one came up with the best score and maybe the second best score. I can't exactly remember the details, but they'd take the top scoring ones, and then you'd combine those ones again. And you just keep going through that process and introduce some random mutations as well. So very much the same way that our DNA changes over evolutionary time as a result of mutation and natural selection. So to do that though, you need lots and lots of repetition of that thing. Now with an AI game, you can run it, you don't have to run it at human speed, you can run it 100 or 1,000 times faster than a human would play the game. You just turn the clock up and everything goes much faster. So overnight you could run 1 million games and lots of it, 1,000 iterations, and you can learn. If you put that technology into a real robot interacting in the real world, obviously it can't live 1 million lifetimes in order to gather enough data to be able to do that. And so whilst neural networks can be great, and genetic algorithms could be great for things which you can repeat over and over again very fast, maybe that's image recognition, recognise a horse or recognise a cat or a dog or a person or something, and you can show it 1 million pictures and get it to train it on that network. Very difficult with something like social interaction, because you can't give it 1 million social interactions. There's not enough time in the world, right? Because social interactions only happen with humans at a certain rate.
Or you could, if you had 1 million different.
If you had 1 million robots. That would.
I feel like the Google Home project and Alexa, Amazon Alexa, and things like that. They are the 1 million robots. They are. And although they're being trained effectively on voice, are not on expressions or anything like that, so it's a limited.
So the lower levels are incredible. I mean, voice recognition technology is amazing now. I don't really type texts anymore. I just dictate them. And I have an iPhone, so Siri gets that incredibly right. It's very, very good. Even with reasonable levels of background noise and me mispronouncing things, and it seems very good. So the lower levels they've got sorted. The higher levels. So what's the semantic implication of that? What's the meaning of my sentence?
What do I actually want you to then action?
And exactly. It requires so much more context, and that's hidden context. It's not in my speech. It's in an understanding of the world. That context. Understanding of my situation and all kinds of other things that you through your common sense would know that I wanted. But the machine wouldn't necessarily know all of those things, and quite hard to learn all of those things. Not impossible, but much harder to learn those things. So whilst we're really good at classifying images and doing video and object tracking and all of that clever stuff that we can do with video streams, we're good at audio. As you go up those layers, it becomes increasingly more difficult to make sense of the world because the information's not there.
Yeah.
So I spoke to some guys at Oxford who were working on a project, a social robotics project. They'd spent 3 years. It was a big funded project. And they were going to have the robot interact with people and then learn, based on those social interactions, how to react appropriately.
Right.
How to get the machine to, for example, how near should a robot be to a person when it interacts with them? You know, if it comes too near, makes the person back away and so on. Just as an example. And what they told me was that they couldn't get enough data to get anything to learn from that data.
Right.
And I said, well, that's because all of that really, really complex stuff about how we behave socially is encoded in our brains.
Over millennia.
It's been encoded. You need a planet.
Yep.
You need evolutionary time, and you need millions and millions of individuals, and then all of that gets codified, and that's a kind of base point, and babies are born with it, and it develops. Now, it's fine-tuned by our human interaction, but in terms of nature and nurture, a huge amount of it comes from the nature, and it's fine-tuned by nurture.
Yeah.
So, a guy called Mark Hauser wrote a book about this. The book was called Moral Minds. I really like this book. It basically says that we have a mechanism in our heads which makes moral decisions. It's tuned by our culture, a bit like Chomsky's universal grammar. So it's tuned by the particular culture that you're in. The words that you use are tuned in the same way as some of the moral decisions you make are tuned by the environment. But you have this very fast-acting mechanism. He did experiments, these trolley experiments, where you just pose ethical dilemmas to people, and found that they make decisions which are far too quick for them to have thought through cognitively from first principles. So they make a decision very quickly, within maybe 100 milliseconds, about what's ethically obligatory, permissible, or prohibited. And then two things happen following that decision. One, that an emotional response happens, so outrage perhaps, or anger, or perhaps some more positive emotions if they feel the right decision's been made. And then a narrative happens, and that narrative is their explanation for why this decision is right or wrong.
Right.
And that narrative varies completely widely by culture.
Right.
Maybe it may be a religious-based narrative, or some other kind of narrative, depending on the culture of the person and where they've come from. But he's arguing that that's not the reason for the decision. That's just the account that they give of the decision. The decision itself is coming from a very fast-acting, pre-trained mechanism that seems to be universal, because the decisions that all peoples make on the planet about what's permissible, what's obligatory, and what's prohibited are very much the same.
Right.
So things like how you should, physical violence towards individuals and that kind of thing. When it's permissible to push someone into the path of something to save more people, or whether it's possible to pull a lever remotely in order that maybe you kill one person instead of killing five people. Those types of decisions seem to be universally agreed upon, even though the narrative reason for them. And some people don't even have a narrative. They just say, well, it's the right thing. I don't know why, but I just feel that's the right thing to do.
So actually, even though we say that we don't have universal ethics, what he's saying is that we might have some universality within maybe a lower level of ethical understanding.
For things, but that wouldn't extend to machines, for example, because we're not evolved to have any ethical decisions about how we should treat machines or how machines should interact with us. We don't have. We're not evolved culturally or biologically to have any ethical predisposition. So, for example, in another project I've been doing, I've been asking people about AI in warfare, militarized AI. So autonomous machines making decisions about which target in a battlefield area to target, effectively who to kill. And the machines are actually able to make those decisions. We have those machines now. That's not theoretical. That's practical machines. And so we've been posing these dilemmas to people and then asking them what they think. And my hypothesis is that they don't have any clear predisposition about whether it's right or wrong. Because there are good things, kind of good things, like you don't have to send your own troops to war, so you don't have to risk the lives of your own soldiers. You can with impunity, without loss to yourself, you can you can prosecute wars. Or defend yourself. Maybe defend it. Maybe that's the other flip side of this. If you have an aggressor, you can use your machines to defend yourself against the aggressor without having to risk anybody. And people don't seem to have any clear moral understanding. No one says, well, autonomous machines in warfare is wrong.
Yeah.
For every person that says that, there's another person that says, well, no, I think there is a place for them. So
Right.
it's very interesting.
So we're not attuned to think about these technological things that we're making in the same way that we might have an instinctual reaction.
So we're
to
not
the human.
attuned. Exactly. That's really helpful. So in the same way, we're not attuned to make decisions about whether socially interactive robots or companion robots for old people, for example, which is an area where manufacturers are moving into.
Yep.
Whether that is ethically a good thing or a bad thing. There's no consensus.
And there's no instinctual reaction.
No, exactly.
Necessarily as well.
Exactly.
Yeah, that's really interesting. Yeah, and it might take us a very long time to then build that base level ethical kind of reaction.
Yeah.
Maybe thousands of years, actually. So what we're going to do in the meantime?
Well, we do advance. I mean, cultural evolution can go much faster than biological evolution, right?
Sure.
And ideas do evolve and so on. If you look at the quality of our democracy, in 500 years, and the quality of the institutions that we have in society. If you just take one particular issue, for example, sexual orientation, in just a very few short years, that has massively changed, ethically. What's acceptable and what's not acceptable has changed dramatically in a very short period of time. So I don't think it necessarily needs to be, but there needs to be a debate. It needs to be out there, and I think we need to hold manufacturers that, as you say, before you turn this thing on, there's lots of people out there who've just never thought about any of this. Some of those people will be building autonomous technologies. If your interest is in machine learning, and you're really interested in the maths of machine learning and how all of that works, and you're trying to build better and better mathematical models, and that's really your thing, and what you really want to do is to be able to absolutely know in advance whether someone is a good or a bad insurance risk, so that you can set their premium absolutely spot on for that person. You may not have thought about the ethical implication of that, which is that if we don't smooth this out over everyone, all of a sudden insurance stops being insurance anymore. Because the way insurance works is that we all share that risk of the whole population. Some of us benefit, some of us don't. But there's a smoothing out that happens. The guys who are just doing all the maths, they're not thinking about that, or maybe they're not thinking about all of that.
Possibly. I think there was a quote that I saw which really struck me on that sort of not thinking side of things from Daimler, the truck manufacturer, who also own. I think maybe Ford as well, and they were creating these autonomous big trucks to be used in America for haulage, and they had made their first big autonomous truck and were testing it and doing a big showcase. And one of the things they said was, what if something goes wrong? What if something happens and things like that? And their opinion was, that's not for us, that's for everyone else to work out. That's for the insurers and the government. And actually that sort of thought process is hugely destructive and worrying for me, that people can be so thoughtless in how they actually interact with the rest of the world, in the things they make and the socially and all these different ways.
Well, it's a huge step backwards, isn't it? Because within their factories there are health and safety guidelines and so on that they have, so there are guards around all the machines, and there's all kinds of rules and regulations that means that people that work in those factories don't get injured and don't get killed and are looked after. And what they're saying is, well, now what we're going to do is we're going to take these machines and put them out there in society, and if they kill people, that's not our problem now.
Until it is.
Until it is.
So we'll retrospectively sort it out. When someone tells us off. But they're not saying we're the thought leaders on this and we're going to help everyone. that, and share and all that sort of stuff, and try and bring this sort of thing up.
And it's also happening so fast. It's very difficult for politicians and legislators to keep on top of all of this.
Have you talked to any legislators or any politicians who actually appreciate the speed and the technological change that is happening? Because I would hazard that very few of them appreciate the technology itself. They might have an understanding of how Siri works because they have it in their hand, but
maybe not the implication of it.
Exactly, the implication, and also actually the underlying technology. How do these things work? And given how these things work, how are we going to legislate against it?
No, I haven't. But it is probably one of the few completely unregulated areas is software. If you look at research into genetics, for example, it's a highly regulated area. You have to apply to an authority if you want to conduct some sort of genetics experiment, and all of that. And if you're a psychologist and you want to do an experiment with people, then again there's an ethics board to be interacted with. But if you want to build a software product that does some cool thing with some sensors and basically a robot, you can just build that robot and sell it. There's no regulation.
We had Cosima Gretton on this podcast, and she's a doctor, and from day one they have this ethical code beaten into them to do with medicine and the Hippocratic oath, and things that they have to adhere to, which technology, like you're saying, doesn't necessarily have yet. In a similar way, just basic stuff, don't do bad things,
professional engineers who sign up to institutions, like the British Computer Society and the Institute of Engineering Technology, those kind of things. I'm a member of both of those organisations. They have a code of conduct for their members.
But they don't have.
But it's not specific. It's not
It's not like the FCA or
no,
something like that, which will come down like a
not specific to an application
you.
domain.
Sure.
No, absolutely not.
Okay, so I think we're getting to the end now.
Okay.
There's two questions I'd like to end on, which I usually pose: is what things excite you about the future, and either the near future or the far future, and what things are worrying you? I think we've probably covered some of those things. What excites you at the moment?
So I don't want you to think that I'm anti-technology or anti-machines or anti-robots. In fact, I think with all powerful technologies there are risks. Okay, so I would be quite in favour of nuclear power, for example, as a way of very cleanly generating very large amounts of energy. Fusion, obviously, let's all hope that fusion works, because that would be even better. But as opposed to burning coal or burning fossil fuel generally, it seems to me a much better idea. But there are huge risks with nuclear energy, so it needs to be very well regulated, very controlled, and people need to be very concerned about that. So, for example, the nuclear non-proliferation and the limiting of nuclear weapons, for example, came about because humans all across the planet were absolutely mobilised about how dangerous all of this is, and that got into the minds of the politicians, and as a result of that, it is incredibly well controlled, and we haven't had rogue nuclear weapons being fired at anyone. There are lots of weapons out there, but it seems to be successful so far. Not saying you shouldn't worry about it, but it seems to be successful. So I think in the same way we just need to say, well, artificial intelligence is an incredibly powerful technology, has many application areas. We just talked about robots mainly today, but obviously there's lots of other applications of AI. Talked a little bit about social media and decisions being made about credit checking and financial decisions that affect your life. There's lots of things where, and weapons and so on. So what's really important is that people understand that this is powerful and therefore potentially dangerous. And our institutions therefore take this on board and generate appropriate legislation, frameworks, the right kind of monitoring organisations and so on, to be able to just make sure that... And we need something with a bit more teeth to control people, product manufacturers, in terms of what they can and cannot do. We have data protection regulations, admittedly, but I think it's almost like something to do with agency and manipulating people by having machines with agency, and that needs to be considered in the way that it isn't. So I'm very bright and positive about the future. It seems a lot of technologies are all coming together. We've got miniaturization of electronics, sophisticated software algorithms, but we're also getting things like very high density batteries, which means you can carry around a lot of power in a small physical size and at a low weight. And there's lots of advances in materials, which means that you're more able to make machines that could do useful things. I mean, I'd love to see a robot in your house that could do useful stuff, as I say, like make the bed, dusting. I don't think we've seen a dusting robot yet.
Yeah.
Don't just have to keep smiling and chatting with you. Yeah, I'd like them to do useful things.
Those are the easy wins, though, aren't they? Embarrassingly, there's something that I always tell people about my ideas about, when people talk about losing their jobs to machines.
Yeah.
I think it's easy to lose your marketing job or your accountancy job to machines because they don't have to have physical embodiments for those things to work.
Yeah.
But cleaners and things like that.
My daughter's a midwife, and I think that's just about one of the last things that's ever going to become
these like
automated,
social, creative knowledge and dexterity, predominantly dexterity-based.
But also
jobs.
caring. Also anything where you want human-to-human interaction for caring purposes. Because, like I was saying, however much these machines are simulating a level of caring, it is obviously simulated. You could argue that a care worker who goes from one old person's house to another cleaning and so on is in some sense not deeply concerned about that person, and they might say, how are you, and in some sense maybe they're being a little bit deceptive, but that's something that we understand. We have some theories of mind for that, but on both sides.
But maybe that's
but not with a machine. With a machine, there's huge scope there for people to be really tricked by assuming that this machine actually cares about them.
So maybe in that way the best option is actually to make a cleaning robot that has no need for social interaction. It does the cleaning, it can do all sorts of
and it may have a voice
stuff.
interface. It may have a voice interface in and out.
But it's not to cheer you up.
But it's not pretending to be something which it isn't.
Well, with that one, I think we're going to call it.
Okay.
So thank you very much, Rob. And where can people find you?
You can find me online, robwortham.com, and all the other links flow from there.
Great. Twitter, etc.
Twitter's from there, so it's at robwortham. So it's all online.
Cool. Thanks very much for your time.
Thank you.